have a motor with a hob on the shaft. And if something like that actually existed, I would be so happy, because that's what that has. And we learned the secret of success, and it turns out doing this is a very simple operation in the machine shop. And that will also be tested tomorrow, because that gives me 4 times the resolution and 4 times the torque, which means I can do it on the small motor, which lightens the mass. It cuts the weight of our printhead almost in half. So that to me is, one of those final details we're looking at. All right, enough about the ABS head. I think you see that we're getting great progress there, and that I like it.
Yes,
I like it.
it's
How about
quite imminent.
since? Yeah. How about since Daniel G here is
Dad,
Oh,
hello.
hey, Chris.
hey viewing world.
I don't know if you heard that. Today's his birthday, so he's over at Granny's house having a good time. So what we'd like to do is show you guys. We'd like to show you guys a super system with a scanner installed on it, and maybe do a little tiny preliminary demo. So first, would you be kind enough to run the camera, and I'll walk them through what the system has on it?
With pleasure.
Oh, you know what? I didn't put the cover back on here.
Nope.
Well, shame on me. Put that out there.
Okay, for you guys who don't know what the super system is, it's basically the same thing as the engine or the system. The engine is just everything that's not enclosed. The system is the enclosed version of it, along with a couple different areas for us for scanning. Meaning we had it set up initially in our Kickstarter. What?
It's been changed,
But
we'll bring you
yes,
up on it
yeah.
right now.
Yeah.
He doesn't know, because I didn't tell him. That's my fault. It
What?
just figured it out today.
Okay.
We've been struggling trying to figure it out. Dan, can you do me a favor and just hold that like that for a second?
Okay, guys.
It's going to take 2 minutes possibly.
Forgive me while I get everything ready. There we go.
Let's see if I can get that in there.
Yes, guys.
There we go.
Here you go.
Thank you for the help. There you go.
Sure thing.
All right.
Alrighty.
That looks a little bit more like the super system. However, it is still lacking one little detail.
Okay.
Did you have fun over Grandma's?
Yep.
Good.
And wait. And hey, one more thing. It's my birthday today.
How old are you? 14?
No, 10. And
10.
Is
But what a
there any-
big guy. Can you guys
is
believe
there
this
any
guy's 10?
yeah. Hey, is there any button pushing I can do?
No,
here?
but you know what? We might need a subject matter. Can you sit really still for a few minutes? Tell you what, he'll be our stunt double tonight. Hang tight about 2 minutes. So, let's just walk through its features. It's 30 inches tall. That's a super system. I hope you have room for it. If you don't, maybe you need a refund. Comes with a single opening door.
Power USA says his son just turned 10 yesterday as well.
Well, awesome. Okay.
Happy birthday. Alright.
What is standard on a super system? You got the 30-inch height. You got the table. It's the same 200 millimeters up and down. It's a little bit longer than the engine on travel. It's approximately, and I got to get a ruler to check it out, but I'll tell you in a second. 295 millimeters of X travel. Okay, and the Y travel is oh, that's with the second head. Yeah, that's right. Okay, 230 millimeters of Y travel. And for those of you that aren't doing metric so well, that's 9 plus inches of travel in the Y. Okay, it comes with. It's okay. It comes with an integrated fume scrubber. which is just a small guy, and so some of you are going to want to invest in a better one, but we're actually framing this in. It fits quite well. We'll print up a little mechanism that's a picture frame for it, and so it's got an activated charcoal filter. All right. It also comes with, and this is standard on the Super System, you don't have to have this again, side-mounted material holder. So that's standard on Super System. The top is optional. It's not going to normally be included on this for the Super System. And it comes with 14-inch display, which we are trying desperately to make into a touchscreen as we speak. And then it has this nice swing arm scanner built into it, which, if you swing it in here, and this is
Well, let me get the cord. So
here, I can move it around for you.
that's right.
Okay. And if you notice, it says Connect. Connect, I'm going to tell you guys a little story. There's a company called Prime Sense. They're located in Israel. They developed this 3D dual camera infrared technology, and Windows got their hands on it in 2009-ish. And then in 2010 said, hey, let's make this into the Kinect, where people can go out and do their dancing, and then it tracks everything. And then they said, you know what, no one's using this technology, let's drop out a SDK, a software development kit, which they did. And now lots of people are developing third-party software for it. One of them is, we tried lots of third-party software the last 2 weeks, trust me, and one of them actually works, which we're going to demonstrate in just a minute. But the reason why this is on a swing arm is so that you can move it out and then do something outside, like a person. Although we're finding out that you're actually better to move the Kinect than you are to move the person so far. We're still working on that. Because the, oh, I didn't show the good part. Where is the good part? Oh, there it is. If you want to scan, of course the glass will be in here, so you have to open the door. And it's not glass, it's plastic. You put your rotary table on here and plug it in to the little connector underneath. I can't see whether that's the right side or not. Yes, it is. Okay. And now that is powered by the computer.
Okay.
All right. And yeah, it rotates and lights up. And I'll give you a demo on that once we get the Prime Sense connector. This is the Microsoft Kinect for Windows, and it is a good place to start, but it is not as good as the, well, that's a very nice shot. It's not as good as the sensor we have coming. The sensor we have coming works at shorter working distances, which means you're going to get higher resolution scans on objects that are printable. Okay, so without further ado, now we can move over and we'll let the two smartest guys in the family prepare to do a scan for you guys. And hopefully we can do a screen share while it's happening. So,
yes, we can.
Christopher, I'm going to set you, you have to sit in your chair. And
Okay.
we're going to let
Give
you.
me 1 second, guys. We'll get the camera set up just for a second. So, just 1 moment.
Now, Daniel's probably going to move the camera while you hold really still, okay? And where would you like him to sit?
You need to
got right
sit
here?
here. Yeah.
From right there.
Oh, sorry.
It's fine. It's fine. I'll move out of the way. Let me just go get this guy. Get the cable up and around. There you go. Now come around to that side. Run the camera.
Now,
And,
this might shock you, but don't jump, okay?
Okay.
Boy, is he
Now-
tough?
Okay, so how do I do the screen share?
Okay. Go ahead and move this guy. Move this window all the way over. That side. There you go. Okay. Now come over to.
Let's move this over here too, just so.
That's fine. Okay.
Okay.
Now click screen 1 capture.
Screen one capture.
Okay. Now come down here and you'll see
Got it. So.
Mesh Lab's already up.
Oh. Sorry about that. Okay.
Right there.
I'm opening up the program right now, and just so you guys know, we're using a Microsoft.
Scott Connect is actually already up too.
Oh.
Yeah.
I apologize.
I guess. Okay.
So this is a 3D landscape that we generated using this Connect software of well, I'm the other Dan, so we call him Hutch around here, but you guys use him always Dan. And as you can see, we have the desk in the background. And I'm going to go back to the. I'm going to end the full screen. Do I go full screen camera?
You can go full screen camera, yeah. That just goes back to that.
So, can I see the camera for a second? Sure. So this shows you guys. You guys just saw that. And here we have the same. So you can see here's the desk, and there's a chair. There was a chair over there as well. So now you guys know what it is we're looking at. So you go back to the screen on capture. Now you can see that here. So now you can see what the entire environment.
Yes.
And there's that portion over there, and that portion has since been moved. So unfortunately, I can't check that. So what we're gonna do now is we're gonna scan Chris, and we're gonna go over here, and we're gonna do a half room. And you can calibrate all these settings. We're in the process of determining what the best settings would be for the scan.
Wait, should I close my eyes or open them?
Open.
Yeah, keep them open.
Natural.
You wanna come over here.
Yeah, just scoot up just a little bit. So you're in the field of view. Okay.
See, look into the camera. And now when he walks around with the camera, you can just keep looking at the same place. You think it's getting driven by the other camera driver? We can unplug the other camera, right?
We can actually unplug this camera.
For the moment.
The only thing is that people wouldn't, everyone you wouldn't see where we are.
See,
So-
Oh, we're fine.
Woohoo!
Alright, so that. Oh, I didn't do that. I couldn't figure out what it is. An instant's still kind of running. Somewhere.
Oh, it didn't shut down.
It didn't shut down properly.
Yeah. We're going to have a lot of fun with the little task sniffer. Make sure everybody shuts down properly. Good thing I know how to do that.
Okay.
So how long do I have to hold this pose?
Well, just a second. It says it can't find the camera yet.
Hmm.
I think it's because I think it's getting. No, I think you're getting dual USB.
I think it's because of the fact that we're using two cameras. But we.
It could be the fact that we're using two cameras. We didn't test that.
Not sure.
It'll be okay.
Just give everybody out there a heads up. I apologize for that. More mechanical difficulties.
Well, we can unplug the other camera for the moment.
Yeah, but how are they going to hear us?
Yeah, the sensor
Oh.
yeah, the sensor is unavailable.
Yeah.
What we'll do is
Maybe
we'll
use
attach
Skype?
some videos to the site, and you guys can download the videos of us actually scanning things. But here, I'll give you another one here. So we have one here from Mesh Lab in Mesh Lab here. So this is actually me, and let's get me up here. So this is me, and I scan myself over here, and it's not perfect, but it's definitely moving in the right direction because we're still perfecting the process itself, and that's kind of where we're going from. So I have a question here. It says the connect resolution isn't very high. Scanning a person okay, but a very small parts with details. The answer is that actually does matter, and we're in the process of perfecting how we can scan the smaller parts, and a lot of that has to do with the thermal imaging, because there's actually a thermal camera as well on there, and that actually makes a large difference. Since the part is above room temperature, it is able to detect that, and it's able to figure it out. So that does matter.
So I guess you got out of it.
Yeah.
How about we scan you tomorrow?
Sorry, there's only
Is that
one I
okay?
can do.
All right.
Let's see here.
All right. Thank you,
Sorry.
Chris.
Other-
Good job.
All right.
Yeah, and I got a question here from Eagle Wange, and it says, we move from lasers to connect, and the answer is yes, and we've been getting much better results with the connect overall. We had troubles getting the lasers to be consistent, and
No, that's not necessarily true.
really?
Yeah.
Okay, my bad.
Yeah.
I apologize.
Let me address that one.
Oh, I'm sorry. But yeah, at the moment we're leaning towards the connect.
Yeah.
Yeah. I'll just you can have a chair.
Thank you very much.
All right.
Thank you, Dan.
Yes.
Appreciate it, sir.
And yeah, I guess we'll have those videos up as soon as possible.
We'll have to figure out why I can't run with two different cameras, but that's a driver issue.
It's-
This is something that's plagued us all week, is that the sensors themselves, the drivers, are not very robust. And I think I was talking with Daniel G. here an hour ago, and we've tried over half a dozen different software packages, and only one worked. So you find all these blogs online saying, oh, this one, oh, that one, and then you end up saying, nope, doesn't work with Windows 8, nope, doesn't work with Windows XP. We went around and around until finally we found one that actually does work if it's the only camera that's active. And we'll go ahead and figure out how to give a better demo for that with the broadcast camera obviously live. The question about the laser, I don't want anyone to be confused. This scanner is a low-end scanner. The Super System comes with one of these, and it comes with the laser scanners as well. But as you know, we're working day and night to get these guys out the door, and I cannot take too much time to push the laser scanners forward. And the laser scanner gives a point cloud. So since my son has been available to help us, and he will be available for maybe another month, we're hoping, that we're taking advantage of the low-hanging fruit. And since we had to go to Mesh Lab anyway, and we saw this video, which a couple of people had brought to our attention.
Yes. Thank you, Kevin. Thank you, Ken. Thank you, everyone.
Yes.
Who was, yeah.
So what we wanted to do is acquiring. So the way it works is you have an object. You find a way to metricize it using something that gives you a mesh cloud. That something can be structure from motion. It can be something that gives a Z depth due to two sensors working together. It can be something that gives you a line scan. It's another thing that can give you a structured light. There are several ways to generate a point cloud. Once you have the point cloud, then you have to work with that image, and that's really where the tougher part comes. You have things like making it watertight, which we would love to have shown you here. I showed it to Hutch just beforehand. That's how we got that 3D image around there. It seals up the vacant voids in your scan to close them up. And it's not intended to be a scan at this time with enough resolution that you would manufacture from what you had just scanned. What we want to do is, we know that a lot of people are not trying to make small watch gears. They're trying to do artistic scans, and so they're going to want to freeze their cat and then spin them on the little table and get a nice 3D scan and then have a clay cat printed out. So cat's dead anyway, but the concept is that there are different uses for this, and that line scanning at high resolution may not be the right move or the right solution in many of the cases. And since the Connect sensor and software was affordable, no, it's not $50, but you know, it's not $1,500 either. You can buy the sensor online for $200. You have to put the software, which is another $125, $150 depending on the euro-dollar exchange rate, and then you have to rub rabbit's foot 3 times. Actually, this one worked pretty good. But the drivers is still an issue. I don't want anybody to think that they're not an issue. It's the reason why we were really, in this case, really appreciate having an embedded PC, because we control that system and the drivers on it. I mean, trying to run this thing on other configurations, all bets are off. So in that case, it might be that we got lucky and did something right there. And yes, it does have color overlay onto the texture. This kid, whoever wrote this, it's a student who wrote the package we're showing you tonight, this Connect. He did a good job. It's not a bad job. It's a very good job. He used a lot of open source stuff, but I think he succeeded where others have not been nearly as successful, I would say, at least for us. So we're looking forward to tweaking this. There's a couple of hacks to improve the resolution. We already tested one of them with good success. So we'll keep working from that side. The laser scanner works with my higher resolution cameras. And yes, I'm still trying to get 100 micron or 5,000th of an inch resolution. Got it? It's probably, there it is. I hope that answers some of your questions on the scanner, and I hope it tells you a little bit better about what the Super System is. There are a couple of other things that I neglected on the Super System. One other key thing that we did on the Super System, just because I'm trying to make this worth you guys' backing it, and I'm trying to say thank you at the same time.
Okay, hold on just 1 second. It's they only want to know if you...
No, I don't need them. Tomorrow.
Okay. He said tomorrow will be just fine.
So see, our guys are dedicated. It's like 9 o'clock at night. They're asking me if I need them to come in and work here tonight. So that was pretty good. Of course, he was playing racquetball till now, but still, he offered, and that's important. Okay, what I was going to tell you is that we replace the Z-axis bearing with a wider bearing. So it's a LWL24 on the Super Systems. That's included, and we've already installed them on the Super Systems. So we did that because we think that those guys who buy the Super System are going to be having a rotary table. It's a little more weight, and you can still handle it on a normal one. We've already tested it, but we just felt like we'd beef it up a little bit. It's one of those little tidbits that seemed like it was worth the investment on our part. And there's an ultimate reason for that. But, I'll show that later. Let's see. We're going to walk down and answer a few more questions here. First one is the Connect resolution isn't very high. That's depending on how you look at it. It is 640/480. However, it uses an interferometry type technique, and I'm quite surprised at the resolution that it can achieve. It's certainly not going to be at the 100 micron resolution under any type circumstances. This PrimeSense has seen the need for scanning smaller objects. So they make a 108 version and they make a 109 version. The 109 version works down to, we're getting reports at 30 centimeters, which is 12 inches. So at that, you're getting a pretty nice looking resolution. Probably you're on the order quarter millimeter or so on your field of view. At least half millimeter for sure. So that's not too bad, considering most of us are looking at artifacts that are in the room. Proof will be in the pudding. We'll scan with it. If nobody wants it, that's okay with us. But I think that we were jazzed by it. The ability to print, like heads of people, seemed like it'd be a lot of fun. So there. Let's see what the next one is. Dual scanners, yes, the Innie and the Audi. Actually, the line scanner I can't run externally very easily, although I'm working hard to be able to do that. But I have an idea for a fixture on how to pull that off. But we'll leave that for later. The internal dual camera, dual laser with the rotary bed is what I envision for being the best highest resolution scanning. The only thing is that if you're scanning something that's really shiny, I may not be able to give you what you want. You may end up having to coat it with some kind of a white type of a spray paint or something like that. Just be warned about that. So we're looking at lots of different ways to pull that off. It's a work in progress. Let's see what we got here. What's the actual resolution of the Kinect for capturing details? Its pixelation is 640 by 480. If you get close enough, let's say you're at 12 inches and your field of view is 90 degrees, you're probably looking at 12 divided by 640.
Well, Eagle 1J, that's a very good point. Spray window frosting from Christmas on the surfaces.
There you go. There you go. I think Pam works real good too. Some of your cooking stuff has a texture to it that highlights real well, and that also comes off. So I've seen a lot of tricks from a lot of things.
We're trying to go.
Whoa! Let me walk through this one at a time. I see what Holdrick's saying.
Yeah.
There is. Okay, we're. The Kinect works internal and external. The laser works right now only internal. Got to spray the window frosting. So someone was asking that. Next one is Holdrick. He says, but shouldn't a scanner at least have the resolution of the printer? To the best of my knowledge, I have not seen a scanner that has anything like the resolution of this printer under $100,000. The resolution of the printer is on the order of 4 or 5 microns in the X and Y and submicron in the Z, so it makes no sense that we would be able to scan at those depths. I think more realistically is,
And actually,
Yeah,
Charlie, you're right.
yeah,
Ideally,
yeah.
the scanner would have twice the resolution of the printer, but that's not what's currently out there today.
if that's what you guys are expecting, we messed up. If you're thinking that we can give you a 3 micron scanner, we messed up big time. A million apologies. And that's why we only did 4 of you guys. So if someone out there who bought a super system feels like we pulled a dirty, rotten trick, please let us know. Because that is not our intention. And we will make it right by you one way or the other.
Well, that brings up a very good question. One of the best 3D scanners that's out there today is by a company called Creaform. And I'm plugging them because they were kind enough to actually let me use one of their scanners when I was up in Washington, D.C., and I got a chance to play around with one of their handheld scanners. Now, one of their little handy scan laser scanners is going for basically about $25,000 to $35,000 for one of the things, and they're claiming between not the micron resolution.
Yeah, 40 to 50 microns.
40, 50 microns, yeah.
So it's 2 mils.
Micron, yeah.
I mean,
This is 2 mils, yeah, which is what isn't that what we said?
it's actually, no.
No.
500 microns.
5, okay.
I mean, you would have to be so close to get better resolution than that.
Yeah. Okay.
Actually, it's probably much better resolution than the feature size you can generate reliably. Not those Z layer height, but the actual feature size. Because I can't make a dot that's 5 microns. No one can, unless you have an inkjet process. I mean, you can't turn on and off a blob that's smaller than your nozzle diameter. That would be a real good trick. So, hey, what can I tell you? I mean, I'd like, you know what, Huldrych especially, because you've been real patient, real quiet, and also someone that I haven't talked too much. If you could tell us what you're trying to scan, I would feel a lot better. If just to understand. And anybody else that was one of those first 4 guys, we already talked to Brian Arandes in California, and I think we're on board with the same sheet of music there. Greg was one of the super system guys, and so we know what he's trying to do. The impossible daily.
And David.
And David Gaipa,
yeah.
who is just a printing maniac. He's a guy who's got too much brains. We love him. So,
okay.
Yeah.
All right. So Huldrych, yeah, if there's something, yeah, just let us know and we'll...
Hey, as technology evolves, the great thing about this is it's got a USB, it's got a PC, it's got a CAN bus. We can keep adding more stuff to it. So,
oh, I like that. Number 1 item is going to be recreating a fantasy baseball league championship trophy. I like that.
I'm pretty sure we can do that right now.
Scan, change year, print. That's cool. That's really cool. I like that. Okay. It says possibly scan the person's head and make them the trophy.
I like that. See, that's where this comes in, though. I mean, if it looks like the face, then you've got it. So, and the nice thing about the point clouds is that as you're doing this, they actually have interpolation to them. So you get a higher resolution in your point cloud than the actual sensor. As the camera moves, it retriangulates continuously, and hence you get interpolated points that are actually real points. They're not fake points. It's not like you thought with 100 data points you're done. It keeps adding more and more points and then starts filling in the texture. I don't know if you noticed the picture that was up on the Mesh Lab, the one that Daniel did of himself, but it was showing very fine detail, veins in the head, and you could see inside one of his ears from the scanning. So, yeah, there you go. What's
Oh no, I'm sorry. The accuracy was to for these guys was up to 50 microns, but the resolution's actually
100 microns.
100 microns.
100 microns. So, and that's from a a very expensive scanner.
Yes.
But we're not trying to backpedal. Again, if somebody feels like they got taken, we are not here to take anybody. So, Lord knows.